Okay, so let's see. Number two for 5A says using the exponential growth model, and we'll assume the 6% one, not the 5.5% one. When would tuition have been about $30,000 a year? So the model from the previous problem was 4,500 times 1.06 to the t because it was 100% plus an extra 6%. So we're taking 106% of 4,500 and then 106% of whatever that is, and then 106% of whatever that is every year for as long as we need to. The question is, when would tuition have cost about $30,000? You could plug in a whole bunch of t's until you find the t value that gets you 30,000 as the final answer. Um, you could graph the thing on Desmos, which we did earlier. Here's the graph on Desmos, and really what we're doing is we wanted to find out when the cost was 30,000. So if I also graph cost C of t equals 30,000, then I can find where they hit each other, and there they are, and it's at about 32.6 years, right? Which really means in the between year 32 and 33, that's when the tuition actually crosses over to 30,000. So in year 33, that's the first year when the tuition is more than $30,000. So we could do it that way. Um, so in fact, let's write down that answer. So if graphically we could solve it like this. So here's the actual C of t function. And then here's y equals 30,000. This is y equals C of t. That's the way you format that. And the place where they intersected was, what was that point? 32.56, let's say. So 32.56 comma 30,000. And this is, if you remember from number one, t is years since 1980. So let's see, years since 1980, 33. Let's round it to 33 years since 1980. So what would that have been? 1990, 2000, 2010. So in 2013, that's the first year tuition passes $30,000. Now, that's solving it graphically. What I want to do is solve it algebraically. And that means somehow we have to get rid of an exponent. We got to get an exponent as our answer. Uh, Now, the way we would set this up algebraically is we'd say, well, 30,000 is supposed to be the tuition. That's the cost. So 30,000 equals 4,500 times 1.06 to the t. Now, if I divide both sides by, let's isolate this 1.06 to the t. So I'm going to divide both sides by 4,500. And these cancel. And then 3,000, I don't know what that is. Hold on. Where did I put it? Oh, here we go. Okay, so if I do 30,000 divided by 4,500, we get 6.6 repeating equals 1.06 to the t. And now we don't have any tricks that, my guess is none of you have learned these tricks yet. There's no trick that you've learned up to this point in this class to solve for the exponent when that's the thing you're looking for. So there's a trick for it, and it's listed down here. There's this thing called logarithms that help you solve for exponents. And so the way it works is something that's in this format can be rewritten into something that looks like this instead. So it starts out looking like this, and then you just rearrange it into this form. And if you notice, the thing that happens is this exponent gets isolated, and everything else ends up over here. And don't worry about what that log BA thing means yet. we'll learn how to say it and how to punch it into a calculator. But for now, you just need to know that's what gets you the exponent. So in this problem up here, let me rewrite it so it looks like the b to the c equals a. So it's 1.06 to the t equals 6.6 repeating. Okay, now in this format, the base, b is for base, by the way. The base is 1.06, the t is the c, and the a is the 6.6 repeating. So if we rearrange it, it turns into c, which is the exponent, t, equals log base b, so base 1.06, of a, of 6.6 repeating. And I'm going to put this in parentheses, even though you don't have to, but I'm going to do it because the calculator will do it by default. Now, on these calculators, there's a way to do that. Let's see here. It is buried in the math menu. I want to say it's in there. And if you go way down here, you see that thing that says log base. If you hit enter on it, it actually formats it kind of similarly to like it is over here. The base is 1.06. And we're typing in 6.6 repeating. I don't want to type all that in, so I'm just going to come up here, highlight it, and hit enter, and that cuts and pastes the thing. And now I'll hit enter again. 32.56 years. Right? So t equals 32.56 years. Therefore, in 2013. Okay, so this log thing is super important. Okay, make sure you get the idea of when you're solving for the exponent, you're really going to convert that exponential form into something called logarithmic form. And then you can isolate the exponent that way and just punch that part into a calculator. Okay.